All right, welcome back. Now let's do another example where they want us to graph a parabola and also identify certain characteristics. So now notice that this is in general form, right? And so we want to put this in standard form. So notice, first of all, right away notice the x variable here is squared. So I know that this is going to be a parabola that's opening up or down, okay? But I don't know anything else until I transform it. So the first thing I'm going to do is I'm going to use completing the square. So I'm going to take these two variables together, and then this is going to be by itself, and then this is going to be part of the constant. So we'll figure that out in a second, but let's take care of this. So this is going to be 4x squared minus, oh, hold on a second. Is there anything I can factor out of this thing? No. No, not yet. Okay, so let's do 4x squared minus 20x plus that minus 8y plus 57 is equal to 0. Now, before I can complete the square, remember I have to have a leading coefficient of 1, which means I'm going to have to factor out a 4. So if I factor out the 4, right? So I'm going to factor out the 4 here. Oops. And that's going to make this a 1, and this is going to be 5, okay? Okay, now I can complete the square. How do I do that? I divide by 2 and square it. So 5 halves squared is going to be 25 fourths. Now, again, whatever I add in here, I also have to subtract, okay? But again, what am I really adding? I'm adding this times 4, because remember the distributive property, okay? So what I'm actually adding in here, or on this side of the equation, if you will, is this times this, which is 25. So I'm going to subtract 25 over here. Okay? So now this is going to become 4 times x minus what? 5 halves quantity squared. All right, now the rest is going to be minus 8y plus 32 is equal to 0. Now what I'm going to do is I'm going to divide everything by 4, because I notice there's a common factor 4, and this is equal to 0. So if I divide everything by 4, I get the same solution set. So because I got a 0 here, I can just divide out the 4. So I'm going to divide everything by 4, and this is going to become x minus 5 halves squared minus 2y is equal to, not equal to, plus 8 is equal to 0. Now what I'm going to do is, this is squared, I'm going to move everything to the other side. So now this is going to be x minus 5 halves squared is equal to 2y minus 8. And so now this is where I'm going to, now remember on this side is going to be my 4 times p, and then times the y variable in this case. So if I factor that out, I get, I'm going to erase this just so you know. So if I factor I have to factor out a 4, right? A 4 times something. Or let's factor out the 2. Let's factor out the 2. So if we factor out the 2, that's going to be 2 times y minus 4. Right? Now, this 2 has to be my 4 times p, right? So let's just see, okay, if you can't figure it out or if you can't see what it is, set it up. So I know that 4p must equal 2. So if I divide both sides by 4, I get p is equal to 1/2. Cool. Now I have my final equation. It's going to be x minus 5 halves, quantity squared, is equal to what? It's going to be 4 times 1/2 times y minus 4. And now I'm done with that part. Okay, so now what I'm going to do is I'm going to erase all of this. Okay, and so now let's write down vertex, focus, directrix, axis of symmetry, and then we'll do we'll graph it and we'll do the latus rectum and the focal diameter. Okay, so right now, where is the vertex? The vertex is going to be located what? It's going to be located 5 halves and 4. 5 halves, comma 4. So 5 halves, comma 4. The focus. Now, P is equal to 1/2, right? This is going up and down, which means the focus is going to be what? 1/2 unit higher or going up than the vertex. So the focus is going to be what? 1/2 higher. So this is going to be, the focus is going to be at 5 halves, comma 4.5. And that's where the focus is located. The directrix, remember the directrix is going to be now the other direction on the other side of the vertex, and it's going to be perpendicular to the axis of symmetry, and the axis of symmetry goes through the vertex. Okay, so since it goes up and down, the axis of symmetry is going to go through the vertex at the x coordinate. So this is the axis of symmetry is going to be at x equals 5 halves. The directrix is going to be what? It's going to be 1/2 unit below the vertex. So that's going to be at 3.5. So that's going to be at y equals 3.5. Or 7 halves. Okay, so I can write this as 9 halves. And this is at 7 halves if you want. Okay, now what else? What else do they ask us? Okay, vertex, focus, focal diameter. Well, let's graph it first. Let's graph it. So we've got this. Let's just make sure we have everything where we want it. So we got oops. So 135, 135. Okay, so let's plot the vertex. The vertex is at 2.5, comma 4. So 2.5 and 4 is right about there, let's say. Is that right? And the focus is at 2.5 and 4.5. So that's going to be right about there, let's say. The directrix is at y equals 7.5, or excuse me, 7/2, which is 3.5. So it's going to be right about there. So if I draw right there, so this is y equals 7/2. The axis symmetry, right, is at x equals 2.5, right, which is 7/2, or 5/2 rather. Okay, so now we just need the latus rectum, right? So with the endpoints, right, we want the endpoints of the latus rectum. Okay, and so that's where we plug into our equation. So now, in this case here, the latus rectum is on the same as the focus, the same, the line segment goes through the focus, so it has to have the same y value as the focus. So it would be at 4.5, right? Or 9/2. And so if we plug in 9/2, let's plug in 9/2 for y and see what we get. So we get x minus 4 5/2 squared is equal to 4 times 1/2 times y is 4/2, or 9/2 I mean, minus 4. Okay, so now we're going to simplify this. So this is going to give me x squared, we're just going backwards, so this is going to give me x squared minus 5x plus 25/4, which is going to equal 2 times, this is going to be 4.5 minus 4, which is just 1/2, which is going to give me 1. So I'm going to get x squared minus 5x plus 25 fourths. And then this is just going to be 1. And then I'm going to subtract 1 from both sides. But 1 is the same as 4 over 4. Okay? So this is going to give me x squared minus 5x plus 21 fourths is equal to 0. Now, here's where I'm going to use the same tactic that I used before, but this time I'm going to multiply everything by 4 to get rid of the fraction. So I'm going to get 4x squared minus 20x plus 21 is equal to 0. And so now I'm going to use the AC method to see if I can factor this, right? So the AC method, I'm going to do 4 times 21, which is 84. So I want 2 factors of 84 that will subtract to give me, well, let me see here. That will add, right? So 2 negative values, right? So this will be good. So this will add. So they both have to be the same sign because this is positive. And so they both have to be negative since this is negative. So 2 negative factors of 84 that will add to 20. So factors of 84 that add to 20. Let's see, 4 times 12. Or excuse me. 4 and 21, nope. 6. Oh, 8 times 12. No, 8 times 12 won't work. 6 and 16. Hold on. 6. Yeah, 4 and 16. 4 and 16 will work. So negative 4 and negative 16. So now I'm going to decompose this. 4x squared minus 16x minus 4x plus 21. So I just want to make sure that works. So 4. Oh, wait a minute. Hold on a second. No, that doesn't work. Hold on a second. So 4. No, that'd be, no, that's, I already did that. 4 times, never mind. Hold on. Okay, so, oops. Okay, it's right there staring me in the face. So if I do, oh, 6 and 14. Sorry, it's 6 and 14. Negative 6 and negative 14. So 6 times 10 is 60. 6 times 4 is 24. That gives me the 84. All right, cool. Okay, so so it should be 4x squared minus, doesn't matter which one, 6x minus 14x plus 21. All right, oops. So now I'm gonna erase this to give myself some room here. Okay, so now I'm gonna group. And so I'm going to get 2 times 2x times 2x minus 3 minus 7 times the quantity 2x minus 3, and that's going to give me what? 2x minus 7 times 2x minus 3 is equal to 0, and of course now we can use the zero product property, and x is going to equal 7/2 and also 3/2. Nice. So 7. So that's going to be 3.5. So x is going to be 3.5. Right here, and then at 1.5. Right there. So there's the latus rectum. Okay. The latus rectum is going to be, the endpoints of the latus rectum is going to be at 4.5 is y. So that's going to be 3/2 and 9/2 and 7/2 and 9/2. Okay, and the diameter, the focal diameter, is the length of the latus rectum, which we know now this is going to be, it's at 2.5, so it's 1 unit to the left and 1 unit to the right, so the focal diameter is 2. Is equal to 2, okay? And now we can sketch the graph, because here's the vertex. So we got this and we got that, okay? So we got our 3 points, right? So if we can find the vertex and the 2 endpoints of the latus rectum, then we got our 3 points to sketch. The rest of it is just details and characteristics, okay? But not part of the graph. All right, cool. I hope that was helpful. Practice.